Hey, what is good, everybody? Welcome back to another video. In the previous video, we implemented our very first quad. Now, if you take a look at this illustration right here, we basically have a triangle which consists out of 3 vertices, and then we have another triangle that consists out of 3 vertices. And when we add up these vertices, we end up with 6 vertices in total, which basically make up a quad. Now, if I go down to the shader right here and I simply just, instead of returning the input color, which we're passing in per vertex, I'm just going to return a float 4, just so that we can have a uniform quad that has only one color. So I'm just going to turn this to be yellow. So I'm just going to say 1.0, 0.0 slash 0.0. Actually, this one should be 1. Like this. So 1, 2, 3, 4. Yeah, so that's our float 4. And when I come back to our content view, we should have a yellow quad, right? So what we want now is, if you look at this, right, you can't really tell that it's made up of 2 triangles, right? However, if I go back into our renderer and I change the number of vertices, actually not the number of vertices, but if I just scale them down, right, to 0.5s, like this, and I save that, and then you will see that our background will be black, and then our quad will be yellow, but then it will be basically halfway in the screen or the viewport. And then basically, if you look at it, you can tell that a quad is essentially just made up of 4 points, right? 1, 2, 3, and 4. But we know that it's basically consisting out of 6 vertices, right? Meaning that it's made up of 2 triangles, right? Now, in graphics programming and game engines and everything, we ideally want to keep a low count of vertices. So instead of having 6 vertices to draw this quad, we would ideally just like to have 4 drawing this quad. So in this video, we are essentially going to do just that. And instead of having 1, 2, 3, 4, 5, 6 vertices, we are essentially just going to have, well, if you guessed it, only 4 vertices. So this code up here, we can simply delete, and then we can also get rid of these vertices that we basically implemented in the previous video. And then when we save this and we come back to our content view, I want you to see what I'm gonna see, all right? And in this scenario, we're only gonna see 1 triangle. And the reason why that is because, yes, we only have 4 vertices, but the GPU doesn't really know what to do with those 4 vertices, right? It knows as the moment it gets 3 vertices, it turns that into a triangle. Hence why we only have this 1 triangle. But then the moment it has an extra vertice that is not accompanied by 2 other vertices, it doesn't know what to do with that. This is where index buffers come into place and index vertices come into place, right? So we basically have to create an array called indices, and then this array is going to tell the GPU how to read these vertices, essentially. So if you go back to our picture here and we look at our triangle, you will see that we have 1 point over here on the top right, and then the other point here on the top left, and then another point here at the bottom left, right? So if we put numbers here, we say 1 is the top right, 2 is the top left, and then 3 is the bottom left. And if we specify that in that order, being 0 being the top left, right, and then 1 being the top I'm sorry, 0 being the top right, and then 1 being the top left, and then 2 being the bottom left, right? We can now reuse these vertices over to form another triangle, right? So therefore now we can say start again from 0, right, which is the top right, to construct our second triangle, and then go all the way to 2, which is basically the bottom left, right, and then go all the way to 3, which is this last vertice that we haven't made use of, and that will basically construct our first triangle. So if I just simply do like this will be our first triangle, and then this one will be our second triangle. And when I save this, we need to basically get the count, right? Which is 1, 2, 3, 4, 5, 6. Now that count will be known as our index count. So up here, you'll see now we're gonna start implementing our index buffer. So to do that, we're just gonna need to write index buffer of type metal buffer, and then create another global variable called index count, which will count or keep track of the number of indices that we have. So in this case, we only have 6, and these indices just tell the GPU in which order to basically draw our quad in, right? Since we have only 4 vertices, so we can basically reuse these vertices in the specified order for us to have 2 triangles which make up a quad. So now that we have our indices and the order that we want to draw our triangle, our first triangle and our second triangle, we can then populate the index count to be equals to the indices.count, which essentially just returns 6. So now we've populated that global variable, and the reason why it's global is that everything so far is actually happening in one file, and which is called the renderer. At some stage later on, we'll basically abstract everything into its own folders in its own files. You know, this will be handled differently in the future, but since everything is just all in one file, yeah, I'm just doing it this way for convenience sake. And then once we have our index count, we can basically now implement our index buffer, whereby we just simply passing in this array of indices, and then we're just allocating memory for it, and then boom, just sending it off to another buffer, a metal buffer, right? And now that we have our index buffer, we need to basically send that to the GPU, which will then send it to the shaders and everything and do its magic, right? So if you look here, whereby we're drawing our triangle, we have something called draw primitives, and then it says the type is of triangle, and then we basically pass in the vertex count. Now in the previous video, we were using 6 vertices to draw our quad. In this video, we're going to be using 4 vertices to draw our quad, but we don't actually have to specify this anymore. So we can simply just delete this line, and then we can use a new line to draw our new quad, and that is called draw index primitives. Reason being is that we're making use of indices essentially. So now that we're making use of indices, which basically tells the GPU in which order to draw our quad, we don't necessarily need to pass in the number of vertices, yeah, the number of vertices. Yeah, it just handles it on its own in J. So what you gotta do now is just fill up this struct. Basically just draw index primitives, give it type of triangle, index count, and then the index type is of type UIint32. So if you look all the way here, our indices are of type UIint32. So just make sure those data types match up, and then we pass in that index buffer that we created over here to store our indices, and then basically just set the index buffer offset to 0, and then the instant count to 1. I won't be explaining this in this video, hopefully in a future video, but when we click save and we go back to the content view, you'll see that we're still gonna see our quad, right? But the only difference now is that instead of using 6 vertices, we're now using 4 vertices. And for you to also see that this still draws 2 triangles, all you gotta do is just set the render fill mode to lines like this, and just click save, and then come back to our content view, and then you'll see that we basically have 2 triangles forming a single quad. So that is how we basically implement index buffers in our renderer using metal. It's really just straightforward. Hopefully I explained it in an easy way to understand. If not, do let me know in the comment sections below, and I will try in the future to be a little bit more specific and a little bit more helpful. So yeah, so that is it for this video. That is it for index buffers. Essentially they just tell the GPU in which order to draw our triangles to form whatever primitive that it is that we want to form. And also they're very good for performance optimizations. Yeah, so it's very good to have this early on in the engine. I don't know if I should start calling this an engine, because I really don't know the direction of the series just yet. Should it be an engine or what? But the whole point here is to get us started working with shaders and understanding how graphics programming actually works. So see you guys in the next one, and cheers.